Lesson 18.2, Task 2. Complete the square for ax squared plus bx plus c when a is a perfect square. Alright, in Task 1 you formed perfect square trinomials from quadratic expressions of the form x squared plus bx. In this task you will learn to perform perfect square trinomials from quadratic expressions of the form ax squared plus bx. Where a is a perfect square trinomial, or where a is a perfect square and a is not equal to 1. Alright, so use algebra tiles to model the expression 4x squared plus 8x. Alright, so again you can see that the x squared tiles are square, the linear tiles are rectangular, and then the individual tiles are just the small individual tiles. So 4x squared plus 8x plus 4. So we need plus 4 individual tiles to fit the rest, to complete that square. Alright, so complete the following statement about the model of 4x squared plus 8x. To form a perfect square trinomial, you need to add 4 unit tiles to create a square shape. The perfect square trinomial that the algebra tile models after you add unit tiles is 4x squared plus 8x plus 4. Alright, so complete the equation to write the perfect square trinomial you formed in part A as the square of a binomial. So what they're saying is now they want us to factor this expression. So it's going to be 2x plus 2 quantity squared. And remember, you can always check these by doing 2x plus 2 times 2x plus 2. And if you multiply the two binomials using distributive property, you'll see that you do get what you started with. So that's just standard form and factored form. Alright, match expressions to complete the table. Use algebra tiles to draw a diagram to help you do this. Alright, so the original expression, we want a perfect square trinomial formed, and then we want to rewrite it as a binomial squared. Alright, so 4x squared plus 12x. Let's draw this. I'm going to make my 4 squared tiles, so let's call this x squared, x squared. Alright, so there's my 4x squared tiles, and then I need 12 x's. So I'm going to, I need 12, so that means I need 6 on each side. So there's 6 on that side. And then here's 6 on this side. Alright, so when I do that, I need to figure out what goes here. How many individual tiles I'll go here. So remember, I'm going to do 3 squared. So that would be 9 tiles I need there. So we're going to have 4x squared plus 12x plus 9. And then we're going to rewrite that as 2x plus 3 quantity squared. So 2x plus 3 quantity squared. Alright, the next one says 9x squared. So I'm going to have pretend like these are my x squareds here. Alright, 9x squared plus 6. So I've got 2 here, so I need to divide that. So I'm going to have 2 here and divide that. So that gives me my 6 here. Oh, I got too many, don't I? Alright, so I'm going to take off this one. I only need 6. I had 12. Alright, so plus 6. So I've got 9x squared and 6x. 1, 2, 3. So I only need 1 additional tile here. So I'm going to say 9x squared plus 6x plus 1. And then to factor that would be 3x plus 1 quantity squared. All right, so now I have 9x squared plus 12x, so that's what I was drawing in the beginning. So if I add one more row here and one more row here, that means now I have 4 individual tiles to make that complete square. So I need to add 4 to the last one, and then 3x plus 2 quantity squared. And you can see each time we start with what's given, but we're trying to make this whole thing to be a square, which, you know, my drawing's not a perfect square, but hopefully you get the point of that's what you have to do to visually see those perfect squares. But that drawing the tiles helps you see how many individual tiles you need, and once you get the perfect square trinomial, hopefully that's easier to factor that as a binomial squared. Remember, this is the first term squared, and this is the last term squared. And the middle term is that built-in part, that 2ab. So really, to get the factored form, you just have to look at the first one and the last one to know what those are. The quadratic trinomial ax squared plus bx plus c is a perfect square trinomial if c equals b squared over 4a. Complete the calculations to show that this is true for each perfect square formed in part C. All right, so we're going to look, remember, you've got ax squared plus bx plus c. So for the first one here, a is 4, b is 12, and c is 9. So what they want to do is say, we could have found c by doing b squared over 4a. So if we do b squared over 4 times a, that's going to be 144 divided by 16. And if you do 144 divided by 16, you'll see that that is 9. So this number here comes from 144 divided by 16. All right, so the second one, you'll do the same thing. If you take b and square it and then divide it by 4a, so b squared is 36. 36 divided by 4 times 9. 4 times 9 is 36. So 36 divided by 36 is equal to 1. And then the last one, b squared. 12 is my b. B squared is 144. 144 divided by 4 times 9 is 36. So that would be 144 divided by 36 equals 4. So this is just showing one more way to find c. So if there's a number in front of the x squared, in the last example, we were just doing half of b and squaring it. But that's when a was 1. When there's a number here, 4a, this is a squared number, you're going to find c by doing b squared over 4a. Consider the expression 4x squared minus 12x plus c, where the value of b in ax squared plus bx plus c is negative. Complete the statement about how to find the value of c that will make 4x squared minus 12x plus c a perfect square trinomial and rewrite it as a square of a binomial. All right, so the expression, all right, so if we want to find this one, we can do what we just did a second ago. We can take b, square it, and divide it by 4a. So this right here, to find c, just take b and square it. So 12 squared is 144, divided by 4 times 4. A is 4 as well. So 144 divided by 16 is 9. And this expression equals 2x minus 3 quantity squared. All right, so we can use that formula there to find that expression. That's all for task 2. If you have any questions, let me know.